understood this. Okay, look at what's going. Now we are flowing. Look what they're saying, average rate. So whether it's average gradient, average rate, average whatever, I already told you, you've got here, you've got a line on that curve. Look at that line. I'm going to make it yellow now. The yellow line cuts the curve, intersect the curve at 2 points. I'm putting a red dot there and another red dot there. So that line, because it intersected 2 points, that means for the line, for the yellow line, I can work out the gradient, the exact gradient of the line. We good, right?
Yeah.
But that gradient of the line in comparison to the curve, it's called the average gradient or average whatever, but it's a gradient nonetheless, average gradient of the curve of the blue line. Yes. And this line, it must be called a secant because it intersects a curve or a graph at 2 points. We good, right? Hence, they're telling you it's a secant. So everything I said, you understood. This one, you know it. It means delta y, delta x. It's just this one here, this stuff here. It's what I was telling you. Substitute x2. All of that, that simply means y2. That means y1. You get it?
Yeah.
Yeah.
Yes.
Even this one here. This one, I showed it to you with the T. I said T2, it's given by T1 plus delta T. Remember, the delta T, we actually use delta X. But some people, they use the H. So that means all of that I'm circling in black, it's actually your X subscript 2. X subscript 2. X2, you get it by X1 increased by a certain amount. That's what it is. But that certain amount, we write it H or delta X. That's what it is. All right. I think it's making. So what's happening in that block, in that equation? It's just different symbols, notations of writing the same thing. I've already mentioned this one already. So the one, let me stop this one. All right, so we've got the rates. Now you understand that one. So that was the average. Now the next one that comes, we're talking about defining the slope of a curve. What is the slope of a curve? We're talking about the gradient of a tangent. This is the instantaneous, this one. What is the slope of a curve? It is the gradient of a tangent. This is 1 point here, the one we spoke about, instantaneous, at 1 point. That's what it is. So I'm just going to write M, grade for gradient, subscript, tangent for you. We good, right?
Yes.
But remember, at this moment, we pretend you don't know how to work it out. Therefore, you must borrow the average method to work out that instantaneous or the gradient or average or speed at a point or gradient at a point, not average. You see, it says slope. This one says average, 2 point. All right, so I think we basically that I'm not going after that. This is basically exactly the same thing. Watch what they say. They say find the slope of the tangent. Now let's change here. This is about grammar here, because they say the slope of the tangent. No, this is the one that says the slope at. This is the one that says instantaneous. Remember? Yeah. And we can't work it out directly. So they must give me 1 point. Look what they say. They say find the slope of a tangent line of the parabola. I mean, to the parabola y equals to x at. There's that word, not between. At t. There's the t. T, the first t, or it's actually x in this case. X is true. So that means we're dealing with x1 is actually 2. But when you substitute, you get the y value to be 4. So we need the x2 now. So we can't use it as 2 as well because we're going to get undefined. Remember that? So x2 must be x1. It must be 2 plus the delta x. Remember delta x here you need values closer to 0. So you can use 0,
Yeah.
1, 0, 0.01, and then 0, 0.001, and then you work out the grade, and then you'll have this repetition. You'll have something like this that repeats. Then it will give you the answer. It's exactly the same thing like that one before. Are we cool on that one?
Yes.
All right. Now, all of that is exactly the same thing, exactly the same thing. Even here, you see, they're talking about the rate of change and tangent lines here. It's the average rate, average gradient, whatever. This is still the same thing. We are basically done with this one, all of this one, but I can show you how to derive that equation.